Hi guys, so we're just going to continue our conversation of solving systems by substitution today. There's really not a little bit we're going to add on with it, not too much, but again, I said this last time. If anybody does still use the textbook, it is coming from section 5.2. So, getting my calculator. Just a quick refresher on how this works. The idea is, well, first of all, when we solve this system, you need technically two pieces of your answer, right? You need a value for X and a value for Y. So when we solve a system by substitution, the way it looks, as I said in the last video, is that you're going to get two different equations in two different variables, usually both involving an X and involving a Y. And in substitution, you're picking one of the equations to solve for one of the variables. It doesn't matter which equation you pick. It doesn't matter which variable you pick. There are certain situations, though, where solving one equation for one variable might be easier. I think my suggestion in the last video was to try to work it so that you try to look for coefficients or variables, that don't have any coefficients, right? Like for this specific problem, the X doesn't have a coefficient on it. So if we solve this equation for X, that's probably the easiest thing to do. That's not always going to happen. There are going to be certain situations or certain systems where none of the variables have any coefficient, or none of the variables, I'm losing my train of thought, sorry. There will be times where every single variable in your system has a coefficient. That doesn't mean it's impossible to deal with. It just means that it might be a little bit harder. I would say try to avoid fractions as much as possible because, picking an equation to solve for a certain variable, you might get fractions, but there might be other choices where you don't get fractions. So that's kind of what we're going for when we do this selection, Excuse me. We're trying to pick equations with variables that when we solve for them won't get us any fractions. Do you know what I'm saying? Again, I say this all the time. Definitely reach out if you have any questions, because I feel like we're 3 minutes in and I feel like half of what I was just saying didn't make any sense. So let me know if what I'm saying makes absolutely no sense. In regards to this specific problem, I'm going to solve this first equation for X because I think that's easiest. All right. In this case, we do have one option with a variable that doesn't have a coefficient. So I'm just going to take, X minus 5y equal to 7 and just solve for X. What's happening in my marker? So X is equal to 5y plus 7. That's what you get when you solve for X. So after you do this, this comes the substituting part. You would take this 5y plus 7 and substitute it in to the other equation that you haven't dealt with yet for X, because that's what we just solved for. So this X right here is getting replaced by a 5y plus 7. So it's negative 6 times 5y plus 7 plus 4y is equal to negative 16. So we're going to distribute the 6. This is negative 30y minus 42 plus 4y is equal to negative 16. And then we just solve like normal. This is negative 26y minus 42 is negative 16 plus 42. So that's negative 26y is something. 26. So negative 26y is equal to 26. So when we divide both sides by negative 26, y is equal to negative 1. Okay? But I was saying before, you need two parts to your answer. You need a y and you need an x. So just because you have the y doesn't mean you're done with the problem. You do need to go plug this y value back into either one of the two original equations. Doesn't matter which one. If you did this properly, you should get the same x value. I'm going to plug it into the first one because I think the numbers are a little bit nicer. So we're going to do x minus 5 times negative 1 is equal to 7. X plus 5, and then subtract 5 from both sides, so x is 2. And because technically this goes all the way back to graphing the intersection of lines, they do intersect at a point. So I will be looking for you guys writing your final answers as an ordered pair, x comma y. So 2 comma negative 1. And that's that whole problem. Okay. Something like this, I think, is actually way, way easier than anything we've talked about up to this point. I know y equals 6 kind of looks a little weird. It actually is an equation. You know, if you guys remember Hoy-Vux from earlier in the year, y equals is the equation of a horizontal line. So that sort of is one of your equations that we already have solved for a variable. So this is what we can work with. And if you actually think about it, right? Y equals 6, that flat out gives you your y value. Like, it's staring you in the face, right? So you already have your y value given to you as one of your equations in the system. So you can just take that 6, plug it into y, and then get x. And the problem is going to be finished way faster than any of the problems that we've done in all the days we've been doing this. So 2x plus 3 times 6 equals 2. So this is 2x plus 18. So this is negative 16. Oh, you guys can't see that. Hold on. Here we go. And then x is negative 8. So again, we have our x value, we had our y value given to us, so we can just finish up the problem by writing it as an ordered pair. Okay? Okay. All right. So, this I think is where I think maybe, we'll see, some things are going to get a little bit interesting. All right? Luckily, this first equation is already solved for a variable for us. We already have it set equal to y, or solved for y. So we're going to take x minus 4 and plug it in to the other equation for y. So negative x plus x minus 4 is equal to 3. Now, okay, so I was right that weird things do start happening. All right, negative x plus x cancels out. So what are we left with? We're left with negative 4 is equal to 3. The variable disappeared completely. All right, so I hope you guys kind of know where this is going. It's today, like the new stuff, quote unquote, of the systems is involving the no solution, infinite solution that I'm sure everybody loves because it's really, really easy. And if you look at it, it's the same kind of situation that we have pretty much every single time a no solution or infinite solution situation happens. When is negative 4 equal to 3? Never. So if this is never true, there are no x values or y values. There's no combination of numbers that would make both of these equations true. Because that's what we're doing when we're solving these systems. We're finding that one pair of x value and y value to make both equations true. If we have something that says negative 4 is equal to 3, that's never true. So we are never going to be able to find a pair of x and y values that make both equations true no matter how hard we try. So because we can't solve this problem, there is no solution. All right? Okay. For something like this, it's the same kind of thing. We already have one of these equations solved for y, so we can plug 3x minus 2 in for y in the other one. And here you got to be really, really careful. 3x minus the entire thing. If we are, like, I could have put parentheses in with the last one where it was plus, but distributing a plus to both of those terms wouldn't have changed anything. Here, distributing a negative will, so that's why you have to put it in parentheses. So minus parentheses 3x minus 2 equals 2. Then when you distribute the negative, this gets you 3x minus 3x plus 2 equals 2. The 3x minus 3x is going to cancel out again, and now you're left with 2 equals 2, which is always true. So the variable, again, disappeared completely. So your options are either going to be no solution or infinite solutions. And because you get something that's true, that makes sense, there are infinitely many possibilities for x and y. So there are infinitely many solutions. All right. Let's see what else is here. Let's do one more, I guess. Just to kind of wrap things up. Making sure everybody's okay. All right, so it's like the same thing, all right? We already have something solved for y. We're going to plug this expression in for y in the other equation. So 2x plus negative 2x. I am going to put this in parentheses this time. Plus 5 is 1. Distributing the plus again isn't going to change anything, so this becomes 2x minus 2x plus 5 equals 1. This cancels out. 5 is equal to 1. That's not true. No solution. All right. And I have a feeling this next one is going to get us infinite solutions, but I hope you guys are kind of getting the hang of this now after 3 separate problems. There are certain ways, like if you guys are able to pick up on certain things as you do more no solution versus infinite solution problems, there are certain things that you might be able to pick up on to help you figure out a lot faster whether a problem is no solution or infinite solution. There are patterns to it. I don't want to sit here and explain it and go through the whole thing because it might confuse a lot of people. And even when you do your assignment on this, I will still be looking for work so that I can see that you understand from an algebra perspective why you're getting no solution or why you're getting infinite solutions and stuff like that, you know. But if you want to know these kinds of tricks, you're definitely more than welcome to ask. All right. But that's all I got for you today. If I just think about this for a second, I'm pretty sure this weekend is Memorial Day weekend, right? Right? I think this weekend is Memorial Day weekend. Yeah, it's Memorial Day weekend. I don't know why I keep rambling on about this. Anyway, my point is, because we are still treating Memorial Day weekend as an actual day off before you guys ask me. So you do have Monday off from school. You're not going to get anything from me on Monday, and you shouldn't get anything from your other teachers. So enjoy the weekend. I hope it's nice. So you should still definitely spend some time outside, even if you still have to practice social distancing and stuff like that. But yeah, that's it. Talk to you guys soon.